Hello, and today we will be learning about arithmetic sequences. But first, what even is a sequence? Well, a sequence is basically the succession of one thing to another, like episode 1, episode 2, episode 3, and episode 4. Or 5, 10, 15, and 20. The terms in these sequences have an order, and we can call them as ace of 1, ace of 2, ace of 3, and ace of 4. Take note of this because we will be using it very often. Now there are two types of sequence. One is a finite sequence and the other is an infinite sequence. A finite sequence is a sequence that has an end, like as shown, while the infinite sequence is one that has no end. You can say so by the ellipsis at the end of the line. Now moving on, how do we solve these questions? First, let's take a look at the formula. Ace of n is equal to ace of 1 plus n minus 1 times the common difference. Don't worry, this formula may look scary, but we'll get the hang of it later. One of the few terms we have to find first here is the d, or rather the common difference. How do we find it? Take the sequence as an example. 10, 20, 30, and so on and so forth. To know the common difference, we'll simply subtract the second term to the first term. The answer we will get is 10, and it's also the same answer we will get when we subtract 30 to 20. Therefore, the common difference is 10. Now that we've learned how to find the common difference, the next step is going to be a lot easier. Let's take a look at our question. Find the seventh term in the sequence 3, 6, 9, 12. Let's take a look at our formula again. Ace of n is equal to ace of 1, which you might remember as the first term, plus n minus 1 times the common difference. We now have all of the terms gathered, so let's substitute them. Ace of 7 is equal to 3 plus 7 minus 1 times 3. Now that it's all set, we can now solve it. Okay, to solve this problem, we first need to multiply 7 minus 1 to 3, and we will get 21 minus 3, since the sign is negative. Now we need to bring down these operations so we won't be confused. Over here, we can now add them from left to right, and our answer will be 3 plus 21 minus 3, and of course, the answer will be... Therefore, our final answer is 21. Continuing on to a different kind of problem. Finding the nth term in the sequence 7, 14, 21, and 28. Again, let's write down our formula so we won't be confused. Ace of n is equal to ace of 1 plus n minus 1 times d. Let's gather the terms that we have, which is ace of 1, and the common difference is 7. We'll be finding the value of n, so we'll leave it as a variable. Now let's substitute terms. Ace of n is equal to 7 plus n minus 1 times 7. And now that we have an equation, we can now solve it. So let's multiply 7 to n minus 1 again. 7n minus 7. Then let's bring down these values. 7 plus 7n minus 7. Combine the like terms. 7 plus negative 7, that will be 0. Therefore, ace of n is equal to positive 7n. And that's our answer. Now, what if the question is asking you to find which term is which? In the sequence 4, 7, 10, and so on and so forth, which term is 22? I'll be leaving the formula here again. And let's take a look at our given. Our ace of 1 is 4, common difference is 3, and our ace of n is 22. So again, we need to substitute our values, and we will get 22 is equal to 4 plus n minus 1 times 3. Now let's solve this. First up, let's multiply n minus 1 to 3. Then we will get 3n minus 3. Let's bring down the values. So now, we need to combine the like terms, which is 4 and negative 3. Our answer will be 22 is equal to 1 plus 3n. Let's transpose 1 and we will get 22 minus 1 is equal to 3n. 22 minus 1 is 21, therefore 21 is equal to 3n. Divide both sides by 3. Cancel that and we will get 7 is equal to n. Therefore our answer is... And that's it for this lesson. I hope you guys enjoyed and please leave a like and subscribe. It really helps me out. Take care and God bless us all. Bye bye.